Welcome back, students. So, we are basically discussing topological based strategies or topology guided strategies, and we have discussed few case studies that how topologically distinct molecules or mainly a target molecule when you have multiple cyclic rings is there in the structure, and sometimes cyclic rings are very complex. You have a like linearly fused cyclic rings, angularly fused cyclic rings, and we have basically instructed that try to follow few normal guidelines whenever you are dealing with the topologically distinct molecules. So, in this particular context, we will be today discussing a particular focus topics which is named as overbred intermediates. Now, overbred intermediates, this particular strategy or this particular concept was used for long time in this field of organic synthesis, but particularly this terminology overbred was given very recently. Now, this basically means that breed basically you are creating excess thing which is not required. Now, probably this whole concept will be quite clear if I give you a transformation something like this. I am saying that I need to make this molecule starting from this molecule, and I set you a prerequisite, do not use the Gilman reagent. Okay. So, now in those cases if you are trying to use the Gilman reagent, which is a straightforward case, is restricted. So, what people are suggesting, you first create a cyclopropane ring to this double bond. So, you are basically adding extra carbon, but you are creating two new bonds. You are creating two new bonds, this one as well as the one. So, means that two extra sigma bonds you are creating, two extra sigma bonds are created. Now, if it is in the target molecule, you do not need that, you basically need one sigma bond. So, means that throughout this synthetic pathway or this final step, you need to keep one extra bond. Now, you may ask that, sir, if we require only one sigma bond, why you are creating two sigma bond? Now, this is basically the concept of overbred. You are creating extra bond or excess bonds or surplus bond. So, excess bond or surplus bond which is not required for your target molecule by initial looking. Now, we say that we will be doing a reductive cleavage through a sodium liquid ammonia. Now, this reaction we have already explained. This reaction basically goes through a single electron transfer pathway. You basically have a radical or this radical here, which is the radical is basically quenched out, give you a negative charge, and this negative charge is exceptionally stable, which can be easily analyzed, and then you basically. So, mainly this extra bond which is not required, we are basically cleaving it, but initial visualization that you have to create extra bond. So, this particular overbred strategy sometimes was very useful, sometimes very useful. Now, if I say that this overbred concept I am discussing at this moment to you, but some reactions involving the overbred intermediate was already discussed to you in this particular forum. Will you agree or not? I am saying that this particular reaction, DMAO reaction, is principally basically nothing but a creation of a overbred intermediate. Now, if you remember the DMAO reaction which you have discussed very frequently or very often during our whole coursework discussion, creation of overweight intermediate through De Mayo reaction. Now, De Mayo reaction, what is that? We said that De Mayo reaction is basically reaction of a 1,3 diketone plus a olefin. Now, initially we says that 1,3 diketone basically will analyze to give you this compound, and then the olefin reacts under photochemical fashion to give you a 2+2 photocycloadduct. Now, this photocycloadduct eventually is nothing but a overweight intermediate, because this ring is now strained. Now, as I said, now this overweight intermediate will tend to open it up through a retroaldol pathway. Now, retroaldol pathway basically it will open up in this way. It will only open up in this way because that will give you the stable carbonium ion, sorry, carbon ion minus here, and then double bond O. So, now the newly created ring is 7 member ring. So, this is your overweight. So, basically these 2 extra sigma bond, this 2 extra sigma bond you have created, fine. This sigma bond is earlier there. Now, what you are doing in this case, you created 2 new sigma bond and then you are cleaving the earlier sigma bond which was present in the molecule, and this was the main concept of overweight intermediate, which was basically well known for long time. I am saying that well known for long time, well known for long time, or you have been practicing it for long time, but this terminology was very recently given, very recently given. So, overweight intermediate are basically in principle, in principle what exactly it is basically a disconnection or fragmentation. It is basically a fragmentation kind of reaction, fragmentation reaction through a strained intermediate, strained intermediate. In usual cases, the overweight intermediates are normally 3 member or 4 member intermediate. 3 or 4 member intermediates are usually regarded as strained intermediate, 3 member and 4 member intermediates or 4 member rings. Now, epoxide won't be regarded as a overweight intermediate. Epoxide is normally quite stable, and epoxide basically can easily be opened up by nucleophile. So, epoxide won't be regarded as a overweight, regarded as overweight. But if you have a cyclopropane, like this kind of cyclopropane, if you have cyclobutane, they will be regarded as a overweight intermediate, and in addition if you have some extra groups which will basically facilitates the ring opening, these are also very useful guidelines. So, usually we always said that a strained carbocyclic intermediate, strained carbocyclic means the ring contains all the carbon. Strained carbocyclic intermediates are named as overweight intermediate, named as overweight intermediates. So, this particular disconnections are basically little bit out of the track, means you are creating extra bonds and then in reality you may not require all those extra bonds. Probably we will give a schematic view. We say this is a and then I am saying that let us say you are having this particular compound, this is a carbon, 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 the ring structure. Okay. Now, I am saying that okay, this is your target molecule. So, in normal scenario you can have other standard FGIs, but if you are trying to use a overbed concept, what I recommend or what I suggest that probably you do a disconnection first, this, and then you put carbon, then you put C double bond O, you first make this bond. So, this is your initial bond or initial strain intermediate. Now, this intermediate is a 3-member intermediate. So, this bond is not required in the target, but if you now clip this bond, you will get this target. Now, 3-member ring was often not easy to make, but there are certain reactions which will allow you to make the 3-member ring. One of such reaction probably all of you know is the carbene addition to a double bond. So, if you have some compound like this, a diazocarbene. Remember in last class we talked about Reggetich diazo transfer. So, this is similar kind of reaction. So, in reality what this reaction will be giving to you, it basically give you a acyl carbene by elimination of a nitrogen. So, you basically get the acyl carbene. Now, this acyl carbene will undergo 2+1 cycloaddition. So, this and this to give you this product, and then this intermediate is now reductively cleaved to give you this target. So, this is a demonstration how this overweight intermediate can be used as a. Similarly, you can have another target. I am just giving you a schematic view, and I say this compound is basically having this structure. It is kind of a spirocycle structure. Okay. Spirocycle structure. Now, I am saying that if you have to apply a concept of overbreadth, you first do the disconnection just by joining this carbon with this carbon, and how the intermediate now looks like. This and this. So, basically you now make the new bond here, new sigma bond here through this cyclopropane or carbocyclic strain intermediate. So, this is your overbreadth. Now, in forward pathway you basically clip this cyclopropane ring to get your target molecule. Now, how this acyclic compound you can get, you now do this 2+1 acyl diazo cycloaddition, which is basically will give you this kind of intermediate. So, you can generate a acyl carbene here, and then it will basically undergo the 2+1 cycloaddition. So, you shine light, double bond C, and then double bond O, you get this acyl carbene, which is now undergoing 2+1 cycloaddition to give you this cyclopropane. So, in principle this acyclic carbene chemistry and this overbed intermediate was known very long ago, and probably people are using it also, but they are not giving this terminology recently they have given this particular terminology which seems to be very useful. Now, what we are trying to do? We won't spend much time. I will just pick particular one example for a target molecule, and then I will see how this overweight intermediate concept was nicely demonstrated. The target molecule which I am now going to discuss to you is a very interesting molecule, and its structure is also very interesting. The structure is having very unique topological features, and this molecule having this structure. This molecule name is longifolin. Longifolin. You count the carbon is C15 carbon framework. This is basically a sesquiterpene. It is a natural product having some biological activity. Now, longifolin, if you see its structural features, whenever you try to get a target molecule, you first analyze its structural features. Longifolin, there are absolutely no active functional group, no active functional group, no active FG. Okay. There is only one exocyclic methylene group, exocyclic methylene unit. Okay. Then it is having 1 and 2 all carbon quaternary carbon, all carbon quaternary means fully substituted with carbon containing center. And then the topology is very interesting. You have a 6-member ring, from the bridge it gives you another 7-member ring which is connected to this part. So, there is a bridge cyclohexane, and then from the bridge it was there. Now, actually this was one of the classic molecule, this longifolin, which attracted the attention of synthetic organic chemists for a long time, and there are few nice syntheses reported in the literature for particularly this molecule, which gives a nice demonstration of how strategically useful reactions can be applied to construct complex carbocyclic structure. Now, for this molecule, if we again do the structure, or I won't do the structure drawing it completely, I will rather do the retro. So, I will initially visualize that if I have something like this 1, 2, 3, if I have something like this kind of intermediate, probably I can, this is basically nothing, a overweight. If I chop this cyclopropane, I will get the gem dimethyl. This was one of the speculation or one of the proposal. So, this is the real overweight which was initially proposed. Now, I will try to further do the retro, and then I will say that now if you have this dicarbonyl compound 1, 2, 3, this dicarbonyl compound, for this dicarbonyl gives you a access to this intermediate or this cyclopropane overweight. Fine. Now, if you see this dicarbonyl structure, you try to count it 1, 2, 3, 4, 5, 6, and this is 1, 2, 3, 4, 5, 6. So, this dicarbonyl was the main features of this particular compound. Now, the disconnection, what I will next draw it probably before that what I try to do, I will just try to analyze in this way. Now, you find that you have a bridge structure and you have something else. The middle ring is basically 1, 2, 3, 4, 5, 6, 7. The guideline is 7 member ring you can basically construct from 5 member and 4 member ring through a DMAO type of reaction, and also DMAO is also cyclobutane containing overbed. Now, you see, if you can connect these two bonds together, your right hand side is 1, 2, 3, 4, 5 and left hand side is 1, 2, 3, 4. So, if you now do a retro and then now connect these things here, this is a particular bond, and then now I am saying this O R, and the central thing you are having a carbonyl. Now, this is what? This is basically a 5 member ring on the right hand side and a 4 member ring with this bridge 1, 2, 3, 4. Now, what is said? If you make this overbraid, it undergoes retroaldol kind of reaction. If your R is H, this is strained. So, it will cleave in this way and this sigma bond will try to cleave and put a negative charge here. This is stabilized by this carbonyl. So, the right hand side 7 member ring we have disconnected through another complex bridge thing is obviously there, a 4 member and another 5 member. So, which basically followed our earlier guideline, and the retro is basically based on a DMAO reaction. Now, this gives you a very crucial disconnection how to now construct the 2 pi and 2 pi system through a intramolecular photocycloaddition. So, now basically what you will be doing it, you just now use a cyclopentene thing with this and then from here I will use a different pen from here, because this is your bridge carbon, from here you have this CO, okay, CO, then you try to figure it out your another 2 pi system which will now give you the another cyclopentane thing is this double bond, and here is your O and R. So, this retro was absolutely brilliant in terms of strategically disconnection. Now, see what I basically is proposing here. You have a 2 pi this point, you have a 2 pi this point, okay. And now we will be basically connecting this 2 pi and this 2 pi through a photocycloaddition, and then basically you will be trying to make this strain overbraid. Now, this particular compound was proposed to synthesized through a Stork enamine reaction, which probably we have explained earlier. So, normally you use a morpholine based enamine. Now, what is normally we know that enamines are this compound where you can easily react to a electrophilic species. Now, this electrophilic species is here a acyl chloride. So, basically now this enamine alkylation takes place and gives you this particular compound. So, now we will do the forward synthesis. So, synthesis starts from this acyl chloride, which is basically you can easily get from this carboxylic acid, and you also react with a cyclopentanone enamine, okay, a cyclopentanone enamine. Now, as I said, enamine alkylation will basically give you, so enamine alkylation will basically give you a diketone, So, this part is your cyclopentanone and this part is your enamine, the double bond which served as one of the 2 pi is here. Now, see this compound is basically a 1,3 diketone, is a 1,3 diketone, is not it. So, this 1,3 diketone you can now simply do a enolization and protect with a suitable protecting group and protection of this thing. So, then what we will get? You basically get this compound, your OPG. Now, this OPG is basically you can simply write it as we have written earlier. This is your one part, this is your this part, then you try to squeeze the bond from here, you have your CO, then your this entire part which basically gives this cyclopentane thing which is OPG. Is it now clear? The 3CH2 remains here, 3CH2 remains here. Now, you do a H nu 2 plus 2 photocycloaddition. So, once you do this 2 plus 2 photocycloaddition followed by the retroaldehyde. So, first basically you will be making this particular bond, this and this, then retrocleavage will give you the intermediate which you already discussed the pathway, that how you can do this. You will basically now get the crucial things 1, 2, 3, 4, yes, you get this particular diketone. Now, for this diketone you have to then basically use couple of other things. Here is one ketone, here is this ketone. Now, out of this 2 ketone, this ketone is sterically more free, I mean sterically less congested, this ketone is sterically buried inside the ring. So, you do a 1 equivalent of vitigilite followed by a Simon-Smith reaction that basically gives you the cyclopropane overbred. Right, and then this cyclopropane overbred you basically cleave with hydrogen and platinum surface. Okay. So, do a hydrogenation. Now, you will find that the cyclopropane will be symmetrically cleaved to give you the gem dimethyl, and here you are having this ketone. So, now you are almost very close, you basically need to introduce the methyl group here. So, treat with LDA and methyl iodide, then what you will get? You will basically get the methyl insertion at this position, the remaining part all are similar. Now, we are almost close to the synthesis. Next step is basically you need to do another round of Wittig reaction to complete the synthesis. The dimethyl is here, 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 and this is your longipholin. Now, this is a absolutely delightful experience or delightful exercises for a exploration of overbreadth concept. Exploration of overbreadth intermediate. Overbreadth intermediate. Now, the take home message is we basically use two overbreadth. We use a cyclobutane containing overbreadth, as well as we use a cyclopropane containing overbreadth. So, both the overbreadths in principle were used here, and the key reaction or key transformation which basically helps you, we already talked earlier, a intramolecular version of DMAO reaction, intramolecular version of DMAO reaction. What is nothing? Basically a 2+2 reaction followed by a retroaldol cleavage. So, now the entire pathway you can basically formulate that starting from a very simple starting materials like this acyl chloride and this cyclopentanone based enamine. They react in a simple straightforward fashion to give you this 1,3-dicarbonyl compound. Now, this dicarbonyl compound enolization is very fast. You basically picked up this hydrogen to form this enol. Now, this enol normally you can basically simply do a protection OPG, then your main 2+2 cycloaddition which basically gives you the 4-member overbreadth. This overbreadth intermediate and the structure we have basically drawn in the earlier part, and we have shown you how this 4-member overbreadth has been really generated. Now, once the 4-member overbreadth has been generated, you remove the PG to make this free OH, then this OH undergoing a retroaldol reaction to release the strain of the cyclobutane system. So, once the cyclobutane strain has been released, you basically get the diketone compound. Now, out of this 2 diketone, as I said, you are having one ketone here, one ketone here. This ketone is basically buried inside the 7-member ring, is sterically more congested. On the contrary, if you have this ketone is free. You do a Wittig reaction here first to get the double bond, then you do a Simon-Smith CH2I2 and zinc copper couple. Then you see that you get another overbreadth. You get another overbreadth. Now, this overbreadth is now again cleaved with hydrogen platinum to give you the gem dimethyl. So, in reality the bond is basically this, you are cleaving this bond. So, surplus bond you are basically cleaving. You get this compound, fine. Your next part is just to introduce the endomethyl group here by LDA methyl iodide. You do it here and then you do a Wittig reaction, one out of Wittig reaction to complete the synthesis. That is a absolutely brilliant visual demonstration, and this particular synthesis is reported by Professor Opolger in 1978. Professor Opolger was one of the brilliant organic synthetic chemists. So, just try to give him a tribute that this synthesis was reported by Professor Wolfgang Opolger, and the entire synthetic scheme was basically demonstrated in the entire slides. So, now you can see that overbreadth intermediate is a very powerful concept through which you can create extra bond, and depending on your requirement you can remove those surplus bonds through a unique fragmentation reaction, but definitely the fragmentation reaction has to be chemically driven approach. or chemically logic driven approach. So, we will try to put this overbit concept as the end, probably overbit intermediate, we are not going to discuss it. In the next class, we will be talking about, next lecture we will be talking about stereochemical strategies, the strategies which are now the final strategies. So, till then have a good time, bye.